My name is Shirley O'Mara, and my project is designing accessible vehicle interfaces, prioritizing functionality and safety for people with disabilities. Background: why accessible vehicle interfaces? As we all know, modern vehicles increasingly rely on touchscreen interfaces and minimalist control layouts. While these may look appealing, they often lack tactile feedback and are difficult to navigate for individuals with disabilities. For example, someone with limited dexterity may struggle to accurately press flat touchscreen buttons, especially while driving. Someone with low vision might have trouble locating essential controls like hazard lights or door locks. Our objective was to rethink interior vehicle controls, moving away from aesthetics as the main driver of design and instead prioritizing usability, safety, and accessibility. Our end goal: to create vehicle interfaces that work for as many people as possible, including those with disabilities. Methods: how we designed for accessibility. The most important part of our process was involving people with disabilities in the design itself. We conducted focus groups with participants from various disability communities and backgrounds. Their insights directly shaped our design criteria. Our research began with reviewing standard vehicle symbol requirements, specifically ISO 2575 from 2021. This standard governs symbols used for controls and indicators in vehicles, which meant our designs had to align with these existing regulations. We also used a data set collected by UMTRI that included images and data on actual vehicle control layouts. This helped us identify which design elements were accessible and which ones were not. Common issues included poor tactile feedback, confusing layouts, controls that are particularly difficult to use, or items that were difficult to find during emergencies. Through this combined research, evaluation, and user feedback, we established key design priorities like tactile contrast, intuitive grouping, and visual clarity. Implementation: prototyping accessible controls. Based on the research and user feedback, I used SOLIDWORKS to CAD a series of prototype controls to 3D print here in-house. First, I designed tactile buttons with high-relief symbols and directional guides to help users feel their way to the correct control. For example, the door lock and unlock controls feature standardized icons, but I added clear, raised elements that can be felt and distinguished without sight. I also used strong color contrast, such as blue, red, and black, to improve visual accessibility. I am now moving toward integrating these into functional electronics using an Arduino Uno microcontroller. The complete system will include tactile feedback buttons, backlit buttons, telltale indicators, and a small OLED display to show settings like temperature or fan speed. These elements aim to support users in real-world driving conditions. Here are some photos of my prototyping work. On the top is my CAD renderings of the proposed HVAC control scheme featuring raised symbols, telltale indicators, and spacing to backlight the buttons. On the bottom from left to right are my tactile lock and unlock rocker switches featuring raised and indented lock and unlock symbols as well as raised L and U in Braille and printed English letters. The next photo is of a rocker switch in the housing that clips onto an existing lock and unlock button. On the far right are the 3D printed buttons for the up and down temperature control featuring high contrast and color cues for improved visibility and intuitive use. Here are my electronic controls at the moment. On the left, I demonstrate using the up and down control of the temperature, and on the right, I show cycling through the fan levels, showing 1 through 4 as well as off. Future work: testing and refinement. The next phase is testing these prototypes with participants who have various disabilities. We'll be evaluating how the controls perform during various tasks, looking at accessibility, comfort, and overall usability. Participants will also compare our control scheme to existing vehicle controls purchased from a junkyard. These controls were identified as poor designs during earlier focus group discussions, particularly due to features that were difficult to use. These tasks will help refine our final system and guide the development of a user-centered control layout. Ultimately, our goal is to produce a set of design guidelines that could inform future industry standards for accessible vehicle controls. I'd like to thank Disability Network and the University of Michigan Transportation Research Institute for their support and collaboration. Their involvement and that of all our focus group participants was critical in making this project successful. Thank you.